Welcome to WB Institution. So today's topic is time division multiple axis. In my previous video, I have explained totally about what exactly is a frequency division multiple axis. In that, I have given the basic concepts regarding this multiple, what exactly multiple axis is, what is multiplexing is. So if you have not checked it, I'm going to place the link in my description box. So please go click it, check it, and come back again. Yes. So today we are going to see about what is a time division multiple axis and its working principle. Yes. See, this is one among the multiple axis technique, that is frequency. In the earlier concept, frequency division multiple axis. Right now it is time division multiple axis. If I recap this frequency division multiple axis, in that different users are got allotted with different set of frequencies. Each user contain a unique set of frequency, that is in case of frequency division multiple axis. When you consider this time division multiple axis, the entire set of frequencies are got given to a user for particular time slots. Means that, let me explain you with a diagram. See, this is going to be my time and this arrow frequency. Okay, user 1, this is going to be my user 2, and this is going to be my user 3. Got it? So I'm going to have a particular set of frequency, that is the entire frequency band which I'm going to transmit. Okay, this is going to be my particular set of frequency, entire set of frequency. Okay, this is used by a user 1 at a particular time slot of t1. Clear? Again, when you consider this second user 2, this entire set of frequency is used by the user 2 at different time slot, that is t2. Clear? The same set of frequency, there is no change, it is not unique. The same set of frequency is used by the user 1 at particular time slot. Again, the same set of frequency is used by the user 2 at different time slot. Finally, if you consider the user 3, the same set of frequency used by the user 3 at the different time slot. Got it? This is the uniqueness of time division multiple axis when you compare it with your frequency division. In frequency division, the frequencies are unique, right? But here, the frequency is common, but it is slotted according to the time, to the different users. So if you consider your definition, you can see that it allows several users to share the same frequency. That is very important. It allows several users to share the same frequency channel by dividing the signal into different time slots. That is what I have explained right now. The same set of frequency is given to different users, but it is divided by different time slots. Got it? Yes. The user transmit in rapid succession. Yes. One after the other, each using its own time slot. So if I'm a user 1 and you're going to be the user 2, for example, if you have allotted a minute for me, in that particular minute I have to transmit or else I have to receive the data, whatever operation according to me. Likewise, if 1 second is allotted for you, in that particular time you have to transmit or receive the information. That is according to your choice. Means that at particular time slot I can do the transmission or the receiving information. Got it? This is what exactly the time division multiple axis is. Yes. So here you can see the technical diagram. Yes, this represents your the x-axis represents your frequency domain, and this is going to be your time domain and the code. Okay, fine. In is, you can see the frequency. If you consider the frequency domain, the frequency is not separated. This is going to be the same set of frequency, a single set of frequency. That's all. It is not slotted or it is not divided, right? The frequency is going to be similar, same, right? But if you consider your time, can you see these slots? Can you see these slots? Means that time slot 1, time slot 2, 3, it goes on till again. So means that the frequency is similar. The time has been slotted for different users. In that particular slot, if user 1 is using at that particular slot, he have to complete his operation. Then it is transmitted to the second user. It has got, travel to the second user. Next, it goes on. Got it? Got it? So this is what explained in your time division multiple axis. Okay. Now, if you consider what is the frame here, means that the informations are got transmitted to a frame. Let me explain it very clearly. See, you can see here, source A means that user 1, user A, user B, user C. Okay, they have given 3 users. Now we are going to deal with 3 users. Okay, you can see these time slots has been allotted. This is, just imagine this is going to be your time slot 1, time slot 2 and time slot 3. Clear? Yes, 3 users, 3 time slots. Okay, if I'm going to allot the 5 seconds for each user, just imagine, okay, I'm going to allot 5 seconds for each user. Okay, in that 5 seconds the user have to, the particular user, if I'm a user, in that 5 seconds I have to transmit or receive data. Then immediately after that 5 seconds, that chance will be transmitted to you. Okay, again you'll be getting 5 seconds. In that 5 seconds you have to transmit or receive data. Then the chance will be moved to the other person. Got it? Got it? The same thing is happening here. See, in the time slot T1, okay, A1, that is the user 1, is transmitting some set of frequency, some set of informations. Okay, this is got transmitted to the frame 1. Can you see here? A1, fine. Next, after the 5 seconds, say the chance is moved to the B1. Again, in that particular time period, B1 is generating some information. Again, it is got stored in the frame 1. It is queued. Got it? Yes. After that, again, at that particular time slot, after the 5 seconds of B1, it is got transmitted to C1. Again, in that particular time period, C1 is generating some sort of information, and that is again transmitted to the frame 1. Got it? Got it? So the entire frame 1 contain the users, it might be a n number of users, first slot of informations. Got it? It is got transmitted. Again, at the second time period, that is T2, again the same thing is happening. Got it? It is a cyclic way of transmission. Got it? Got it? That the frame is a cyclic pattern of transfer. Once the information has been transmitted, again it comes to the time period 1. Got it? So this is what explained in this time division multiple axis frame. Got it? Yes. Now let me explain the frame structure total clearly. Okay, now one time period, a time division multiple axis frame contain 3 segments. One is going to be your preamble, the next one is going to be your information message, and the third one is going to be the trial bits. Okay, what is this preamble? It has the information of address and the synchronization bit, which is used by the base station subscribers to identify each other. Means that it gives the identity to each bits. Got it? The preamble means that, say my name is Shimi Christie. N number of people will be having with my same name, but my initial is something different. Okay, my initial is G. It's not that compulsory everybody will be having a G. Might be, but it's not that much. Okay, so likewise the preamble gives a identity to a particular bit. Clear? So for that reason only, the preamble is situated in the first block. Got it? Next one is the information message. This is going to be the total information which is generated by the users. Okay, the information message has the total information which is generated by the user. Under the information messages, you can see some slots, slot 1, slot 2. Under these slots, the information which is provided by the entire user will be present in this information message. Okay, so if I consider this each block separately, means that each slot separately, you will be having a trial bit, you'll be having a synchronization bit, and the information data's guard bits. Let me explain it separately. Okay, so if you consider this trial bits, okay, you can see the trial bit in the first segment in the slot and the last segment in your single frame. Yes, what is the difference between the first and the last? What it is necessary to place the trial bits at the last and the first of the frame? Okay, so actually this trial bits are very efficient for power controlling mechanism. How they are stating that? Okay, just imagine or just consider this last trial bits. Okay, this trial bits are used to power down, means that it will implies that the data transmission has been stopped. This trial bits at the last of the frame is used to power down the data, means that the information transmission has been completed. It resembles that. Got it? This is for power down operation. Okay, and this trial bits are used for power up the mechanism, means that in order to start the bit transmission, power up the mechanism it is used for, in order to transmit, in order to boost up the bit transmission. For that purpose only the trial bits are present at the first of the frame. Okay, first bit of your frame. Next, synchronization bit. This synchronization bit is used to synchronize your transmitter and receiver bits, in order to synchronize your transmission and your receiving bits. Clear? Next, information data. It holds the entire data which has been sent by your users. Got it? Next is your guard bit. This word sounds quite familiar if you have checked my previous video, that is a frequency division multiple access. This guard bits can also be called as a guard band, means that it is used to avoid the inter-symbol interference between the two users. Okay, in order to avoid the inter-symbol interference between the two user slots, it is used. The guard bits are used here. Hope you are much more clear with this, what exactly a time division multiple access frame structure. And now let me explain you about overhead. Okay, a word called overhead. Fine. So what is overhead? See, in the transmission, I have told you that a single TDMA frame contains preamble, information message, and the trial bits. Right. In this particular frame, the exact information is holded only in the information message bit, in that particular segment, right? That holds the entire information which is transmitted by all the users. But if you consider the bits in the information message, seems to be very less. Okay, in order to enhance the transmission, there is an add up of several bits. That can be your preamble, that is your synchronization bit, that is a identity bit or the advising bit, and a trial bits. These are the additional bits which is used to enhance the transmission or receiving operation. Okay, so these additional bits are called as the overheads. Clear? Apart from the information bits, information messages, the other bits which is present in this particular frame. See, this is going to be the information bit area. Okay, so let me change the color so that it will be very helpful for you to identify. Okay, see, in this particular frame, this information message is said to be the message signal or the exact messages which is got transmitted from the transmitter or the users. Okay, so the other than that, the preamble bits and the trial bits are said to be the additional bits which is used to enhance the transmission operation. Okay, so these additional bits are said to be the overheads. Clear? Okay, now we will discuss about some of the features of this time division multiple access. Okay, the first point explains a time division multiple access divides the entire radio spectrum, that is the entire frequency, into a time slot, say into a separate individual time slots. In each time slot, only one user is allowed either to transmit or to receive. That we are very much clear about that, right? So each user will be allotted with different time slots. In that particular time slots, the user can transmit or else receive the data according to his choice. Okay, each user occupies a cyclic repeating time slots that I have explained to you in the previous while I'm explaining the framework, right? Each frames are transmitted once. See, if for example, if I have 5 users, the frames are got transmitted from user 1, 2, 3 till the 5. Again from the 5 it is transmitted to the user 1. This process is said to be a cyclic process, cyclic repeating time slots or the frame slots, right? Okay, now next point seem to be, let me change the color. Yeah, next point is said to be time division multiple system or access transmit data in buffer and burst method. Okay, let me explain this very clearly. See, for a particular time slot, for example, again I'll go back to the example. If I'm supposed to transmit my information within 5 seconds, I have transmitted. After transmission, again I will be supposed to generate the information in order to transmit in the next cyclic. Okay, so I won't be stopping, I'll be generating the information. Okay, after the slot reaches you, you will be loading the information and it is transmitted to the other user. Meanwhile, you will be generating the other informations. Okay, this process, the information which I am generating after my time slots are get stored in a buffer. Okay, once my chance has been occurred, this will be transmitted to the frame. This process is said to be a buffer and burst method. Clear? Okay, this makes the transmission a discontinuous. Of course, see, this is going to be a user 1 and this is going to be a user 2. Okay, A and B. If A has a chance of transmitting the information for 5 seconds, he will transmit the information, then it is transmitted to the B. At that particular 5 seconds, the B will be loading the information. After the chance has been over by the A, it will continue generating the information. Okay, it will continue generating information and this is stored in a buffer. That is what I was explaining you. That will get stored in the buffer. Once again, during the cyclic process, once again the chance will be given to a source A or the user A. From the buffer, the information is got loaded to the frames. This is called as a buffer and burst method. Since it is not continuous, right? You can see that see that particular chance has been over by the which is given to your user 1. After that, it is get transmitted, it is got breaked and transmitted to user B. So it is not continuous. The transmission of information is seen to be a discontinuous fashion, right? Okay, the handoff process is much simpler in case of a TDMA system. So in case of this TDMA, time division multiple access, it holds a very good time slots which is used. It can be easily switched from one base station to another base station because it holds a very good time slots. Because of that, the hands-off process seem to be a very simpler one. Clear? Next, the system uses TDMA, TDD or TDMA, FDD methods for duplexing. What is duplexing, ma'am? It is a bidirectional communication. It can transmit or receive data bidirectionally. Clear? Duplexing and multiple accessing. Okay, see, if I consider this TDMA TDD, it holds only a single frame. Okay, it holds only a single frame. See, for this particular single frame, here forward link and the reverse link has been accessed. Clear? So the first half is being accessed for forward link and the second half has been accessed for reverse link. Got it? Got it? How these single frame have been divided. Clear? Now TDMA FDD, in this, that is a time division multiple access FDD, in this it holds two different frames. Clear? It contains two different frames. Okay, so that the forward link and the reverse link can be carried out by the each one, right? Two different frames. One is used for your forward link, and for the other one is used for your reverse link. Clear? Clear? Yes. Now the final point says that transmission rate is very high. That seems to be a very advantage for this time division multiple access because of adaptive equalization. Let me make this clear. See, in frequency division multiple access, we will be having a different frequency slots which is allotted for different users, right? The maximum frequency range is about 30 kilohertz that I have explained clearly in the frequency division multiple access. Okay, but when you come here, that is your time division multiple access, the time has been slotted and allotted, but the frequency is seen to be a full bandwidth is given to the particular user. Because of this reason, the transmission rate seems to be very high. Okay, clear? Hope you're very much clear with this topic, right? So we have come to the very important segment of today's topic, calculating the efficiency of TDMA. See guys, this is going to be very important in any of your competitive exams. There is a lot of chance to ask questions from this segment. Got it? So make sure that you're clear with this. Efficiency of TDMA. See, when you compare with the frequency division multiplex axis, the efficiency of TDMA seems to be very important. Why? Because here the efficiency calculated with respect to the overhead bits. Already I have explained what is a overhead bit is. Right. See, in a transmitted entire frame, by calculating how much percentage of information carrying bits and how many bits represents the overhead, gives the entire value for the efficiency of that particular time division multiple axis. Means that overhead bits plays a vital and major role. Without this overhead bit, it is quite impossible to transmit the time division multiple axis in the transmission to be carried out in this time division multiple axis. Why? Because because of the presence of this overhead, the transmission is being enhanced. The transmission is very good in this time division multiple axis. Okay, so we'll check how the efficiency is being calculated. See, always the efficiency in this time division multiple axis is calculated by eta f is equal to 1 minus BOH divided by BT into 100. Okay, this is the formula to calculate your efficiency. Clear? Eta f is equal to 1 minus BOH is the number of overhead bits per frame, and BT is the total number of bits per frame. Clear? Clear? Now, this BOH can be calculated by using a formula. BOH is equal to NR into BR plus NT into BP plus NT into BG plus NR into BG. So this is the formula in order to calculate your B of OH. See here, NR is the number of reference burst per bit. Clear? Per frame. Clear? And BR is said to be number of overhead bits per reference burst, and your NT is said to be your number of traffic burst per frame, and your BP is said to be the number of overhead bits per preamble in each slot. And finally, the BG is said to be your number of equivalent bits in each God time interval. Clear? So NF is said to be your, eta F is said to be your efficiency of time division multiple axis. You can calculate by using a formula 1 minus B of OH divided by BT into 100. B of OH can be calculated by a separate formula just given here, and BT can also be calculated by a separate formula. BT is equal to TF into R. Okay, here TF is said to be frame duration and R is the channel bit rate. Clear? So these are the important formulas which is used to calculate your efficiency. Hope you're very much clear with the entire topic, time division multiple axis. So thank you.